Today we're taking a look at solving our absolute value inequalities. So for our do now, I just want you to look at each of the absolute value inequalities and determine the integer values of x that make each of the statements true. So let's start with absolute value of x is less than or equal to 4. So I know that if x is 4, absolute value of 4 is 4, that's going to be less than or equal to 4. Okay. If I take the absolute value of 3, it's going to be 3, which is less than or equal to 3. Same with 2, with 1, with 0. Now, when is that pattern going to stop? Because it's going to work with -1, right? Absolute value of -1 is less than or equal to 4. -2, -3, and then -4. Once we get to -4, absolute value of -4 is +4. That's less than or equal to 4. Would -5 work? No, because the absolute value of -5 is 5, which is not less than or equal to 4. So -5 would not work. So we'd include all the integers from -4 to 4, or really all the numbers between -1 and 4, if we take that conversation and expand it out of the integers. Let's look at B. Absolute value of x is greater than 7. So would absolute value of 7 work? No, it's not going to be greater. But the absolute value of 8 would work. 9, 10, 11, 12, and so on. We said 7 wouldn't work, 6 wouldn't work, 5 wouldn't work. Nope. But absolute value of -8, that would work. Absolute value of -8 is 8, and that's going to be greater than 7. And then -9, -10, -11, and -12, and so on, up to -infinity would work, because the absolute value of -24 is 24, which is greater than 7. So we're looking at all the integers, or all the numbers, greater than 7 and less than -7. C, we have the absolute value of x is less than 3. Well, absolute value of 3 is 3. Is that less than 3? Nope. But 2 would work, 1 would work, 0 would work, -1 works. Absolute value of -1 is 1, which is less than 3. -2 works. Would -3 work? No, because the absolute value of -3 is 3, which is not less than 3. Would -4 work? No, because the absolute value of -4 is +4, which is not less than 3. Okay. Now let's look at D. Absolute value of x is greater than or equal to 12. So I think it's easy to see that 12 and all our integers greater than 12 are all going to work. What about any negatives? Well, -12 would work. Absolute value of -12 would then give you +12. And all the negative values smaller than -12 would work, because the absolute value of -15 is 15, which is going to be greater than 12. So they would go on like that. Now let's continue our conversation with the do now, but let's change it just a little bit. Rather than just thinking about all the integer values that make the statement true, let's talk about all numbers, or the all real numbers that make the statement true. So talking about decimals, fractions, and so on. And let's work on modeling that on our number line. So how can we model all the numbers, not just the integers, that work for the absolute value of x is less than or equal to 4? So we said it can go all the way up to 4, +4, and all the way down to -4, because the absolute value of -4 is +4, which is less than or equal to, and we have all those numbers in between. So to model that, it can be equal to 4, and equal to -4, and we're going to include all those values in between -3, -2, -1, 0, 1, 2, 3, and 4. We can show it that way on the number line, which would be a conjunction, right? So we can actually model this absolute value as a conjunction that x is less than or equal to 4, and -4 is less than or equal to x. So -4 is less than or equal to x, and x is less than or equal to 4. That's another way we can model that. We could also model that using interval notation from -4 to 4. For b, that one we have to do a little bit more adjustment work, okay? As we change from talking about integers to talking about all real numbers, we know that x can't be 7 because it can't be equal to 7. It has to be greater than 7, but it can be super, 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 super close to 7. So we're going to use 7 on our number line. So we said it can't be equal to 7, but it can be really close. So we're going to do an open circle. And we included all the positive integers above 7. So when we talk about real numbers, we're also going to include 7.001, 7.2, 7.5, and so on, all going towards positive infinity. Likewise with the negatives, we've got -8, -9, -10, -11, -12. When we talk about all real numbers, we can use decimals, numbers really close to -7, like -7.01, because that's going to be positive 7.01, which is going to be greater than 7. So we're going to show that on the number line as -7 with an open circle, and we're going to shade to the left to include that -8, -9, -10, -11, -12, and so on towards negative infinity. And what we can see here is we've created a graph that is a disjunction, right? Or one of our OR inequalities, which we could model as x is less than -7 or x is greater than +7. Okay? And similarly with our interval notation. For c, absolute value of x is less than 3. As we now talk about real numbers, yes, we can't include 3, but we could include 2.999 and -2.999999999. So on our number line, we're going to use 3 and -3, but with open circles because they can't be equal to. Okay, and then where's 2.99, 2, 1, 0, -1, and -2? Those are all in the middle. And again, we've got another conjunction or another and inequality, which we can model like this. -3 is less than x, and x is less than 3. And then we have d. Okay, so we've got all our real numbers in between -12 and +12. So we can model that, our number line, sorry, not in between -12 and +12, greater than or equal to +12, and less than or equal to -12. So here we get another disjunction or another OR inequality, which we can model as x is less than or equal to -12, or x is greater than or equal to 12. Okay. What did you notice about the inequality symbols when we had an AND inequality? Both A and C wound up being AND inequalities, and that was when we had our less than symbols, or less than or equal to, with our absolute value on the left. Those are always going to give us an AND, or a conjunction structure of an inequality. Okay? On B and D, we saw that whenever we had a greater than or equal to inequality, we wound up with an OR inequality, or a disjunction. Okay, and let's take a few more notes about that, how we see that. So here we have absolute value of x is greater than or equal to 3. So I see a greater than, and I think to myself, great, and I know this isn't how it's spelled, greater. So that's or more than, I think more is or. So I know it's going to be a disjunction. Okay. So all the values that make x is greater than or equal to 3, absolute value of x is greater than or equal to 3, that means it could be 3, and all the values bigger as a positive. It could be -3, and all the values smaller. Okay? And where does this come from, that idea of a disjunction? Well, the way we write it is we think about it again with those two cases. When we write the positive case, right, we just take what's inside out, keep everything the same. X is greater than or equal to 3. That's our positive case. When we make our negative case, we're taking this number 3 and we're making it negative. We do that by multiplying by -1. And whenever we multiply by a negative, we have to flip that inequality symbol. So that's going to make it less than or equal to -3. So we're getting that disjunction. X is less than or equal to -3. And as a final answer, we would just write it in that disjunction notation, just like that. Okay. On the other side of that, if we have less than or equal to, I always think of this one, I think of it as, I sort of read it to myself, less than, and is going to be a conjunction. Right? So we're going to have all the values, including 3 and -3, and everything in between. Okay? If I know from my rule, absolute value with the variable on the left, less than is going to be an and, I can just write my conjunction inequality. Otherwise, thinking about it with our two cases, when we go and make our positive case, right, we take what's inside out, leave it alone, everything stays the same. When we make our negative case, right, x stays the same, we have to negate our constant -3, and then when we're doing that, we have to flip our inequality symbol because we multiplied by a negative. Right? So x is greater than or equal to -3, x is less than or equal to 3, that shading's in the middle, right? So when we graph, we see they're converging in the middle of the shadings, and we need our answer to be a conjunction. Okay? So let's put that into practice in our booklet. So in our booklet, I'm going to remind myself that if I have less than or equal to, that's going to be an and inequality or a conjunction. And that if I have a greater than or equal to, that's going to be an or inequality or a disjunction. Okay, so let's take a look at that. So we have the absolute value of x minus 6 minus 3 is greater than or equal to 1. I don't want to make a judgment about the inequality symbol until after I've isolated that absolute value bar. So I'm going to add 3 to both sides. Absolute value of x minus 6 is greater than or equal to 4. Now that I see that, I'm going to look at my inequality symbol. It's a greater than, I'm thinking more is or, so I know it's going to be a disjunction. So that's going to help me as I go and make my two cases. So our positive case, x minus 6 is greater than or equal to 4. Our negative case, x minus 6, we've got to flip our inequality, is less than or equal to -4. Now, we didn't have this issue beforehand because we just had x in the absolute value bars, but now we've got to go ahead and solve each of these inequalities. So we've got to add 6 to both sides, x is less than or equal to 2, add 6 to both sides, x is greater than or equal to 10. Now we said this is going to be an or, a disjunction, so I know I've got to write it x is less than or equal to 2, or x is greater than or equal to 10. I also could have waited until I did my graphing to confirm that it's a disjunction. When we're graphing on the number line with our absolute value inequalities, it's okay if we just put our two critical values and then make our graphs. Right, we've got our disjunction showing all the values less than 2, all the values greater than 10, and then we can do our interval notation also. Let's look at our next one. We've got 3 times the absolute value of 3x plus 2 is less than 12. Again, not going to make a judgment about the inequality symbol until after we isolate the absolute value bars. So we're going to divide everything by 3, which gives us the absolute value of 3x plus 2 is less than 4. Okay? Since our inequality is a less than, it's going to be an and inequality or a conjunction. So that's where I'm thinking I'm going to have our x in the middle and then our two critical values on the side. I don't know what those are yet, but that's how it's going to be structured. So if I'm using that rule, I know it's a conjunction, just start and write it as a conjunction, right? We know we're going to have 3x plus 4 in the middle. Inequality symbols are going to point the same way. And then we're going to have our positive case and our negative case. So right there's our positive case. And then there's our negative case. And now we just solve the conjunction. So I can subtract, oh, I wrote a 4, but it's actually a 2. Oops, let's go back and fix that. Caught that quick enough. So there we go, plus 2. So then we're going to subtract 2 from all 3 sections. So negative 4 minus 2 is negative 6, is less than 3x, which is less than 2. And now we're going to divide everything by 3. Negative 6 divided by 3 is negative 2, and that's less than x, and x is less than 2/3. So there's our conjunction. Okay, you might be thinking, oh, it's annoying, we have a fraction. That's okay, absolute value inequalities. Just go and put your critical values on your number line and make your graph, because with the absolute value inequalities, it's very unlikely they're going to work out so nice and have perfect spacing. And then last but not least, our interval notation. Okay, so to recap for us, we're going to isolate our absolute value bars. And then depending on what our inequality symbol is, if it's greater than or equal to, it's going to be a disjunction. We split into our two separate cases and solve. If it's less than or equal to, it's going to be a conjunction. So we put our separate cases on each side, the positive case and the negative case, and then graph in those same ways. So as you practice, definitely a good idea. Take your time, stop and think about your inequality symbol, and check the answer keys.